And all right. So we still have Riley, Luke, Logan, Abby, Lilia, Ramon, Jessica. Math. So why don't you all get your math notebooks out? Excuse me. Okay, Luke, you'll be right back. You come back, bring your math notebook. And let me get what I was going to get going on here. I can get rid of that. No, I don't want to save that. Okay. So, there we go. Let me share my screen so you guys can see this. And there we go. Okay. Now, do I still have, where is it? Looking for my, that thing, there we go. Okay. So, what we're going to do today, folks, is you have your module test coming up in module 2 test, sorry. And let me drag this over here. Everything got rearranged on me. Hold on. There we go. Okay. And put him over here. There we go. Okay, now we're in business. So your module test is coming up next week. Just a reminder that we do have DBAs to schedule. Today we're going to do a review. This is not our DBA. I want to do traditional DBAs this time, so you guys will need to schedule a time to call me, and we'll do it that way. Who could tell me when the math module 2 exam is? And let me open up my chat box again so I can see your chatty remarks. There you go. Yes, some of you are not in this math class. So this review that we're going to do is mostly for Math 7. However, this is a good review for everyone, including you, Luke, and for those of you that are in Alex, who are just in Alex right now. I'm not sure if any of you who are on right now are just in Alex. I think one or two of you might be taking Alex as a supplement. Hold on a second. There we go. Riley's back. Welcome back, Riley. Okay. So let's get started. What we're going to do, we're just going to go through this review together. Since there's not that many of us on today, we're just going to kind of run through this, and whoever wants to chime in can chime in. Oh, yeah. Mute Elaine's computer. There we go. It's probably getting high again. I'm over here now. Let's see here. There we go. Is that better? Hopefully so. Okay. Oh, wait. I need to do this a different way. Hold on one second. Yeah. There we go. Okay. Now I think I'm ready. So most of you have finished, that are in Math 7 have finished all the assignments. So that's great. So you should be ready to go for this. This was a short module too. We only had really 2 assignments due in this whole module. So it was kind of a short one. But there's good stuff in here. And also, I hope no one skipped lesson 2.2 because there was no assignment for 2.2, but I hope that you guys still read through the lesson, because if the lesson is there, it's important to read through. So make sure you go through all the lessons that are in the module and take notes. All right. So here's our first question. And we're going to do 8 questions here. These are all questions that you could see similar on the test, part 1 or part 2. So simplify negative 6.5. And when you see those, parentheses and there's right next to each other like that, what does that imply, or what does that mean? What operation do you do there with that negative 6.5 and that 2? Is that adding? Is that multiplying? Is that dividing? Or anything? What do you think? Multiply. Yes, Jessica got it. And Abby got it. X, multiply. Perfect. So it's multiplication. So I'm going to let you guys take a look at that. In your own math notebooks, write that question down. And you can write this as a review in your math notebook. So this will be great examples for you to have for the test. And you can use your notes on your exams, right? So it's good. So I'm going to give you 30 seconds to shoot me an answer to that one, and we'll see what we get. Questions on the screen. Can you not see the screen, Ramon? Screen is frozen. Can everyone else see the screen?
Yeah.
Patrick, yeah. Okay, good.
I can see what I want.
Yep, negative 65. Lucas can see it. Or 6.5. Oh, that's your answer, Lucas. Sorry. So Lucas got an answer already. All right. Thank you, Lucas. Those of you that are online, please turn your cameras on so I know you're there. I know a couple of you are having technical difficulties, but those that have working cameras, I need to see your shiny faces.
Is it 6.5 times 2? Is it times?
What was that?
Is it times or multiply, or is it times or subtraction?
So we decided, Jessica answered that question for us, that when you see these terms inside parentheses like this, and the parentheses are right next to each other, that means you multiply. All right. Oh, Lucas has changed his answer. He's now said 65. Who else? Who else?
It's 60 negative, or it's 65 because there's only one negative.
It's 65 because there's only one negative.
Yeah.
Well, I see 2 negatives. There's negative 6.5.
Oh, sorry, 2 negatives.
And there's negative 5, yes.
Yeah,
so what happens when you multiply negative times a negative?
You get a positive.
You get a positive, right?
Yeah.
Perfect.
And then you times that by 2, and that's 65.
Perfect. So let me just, whoops, hold on. Let me show you on my whiteboard here. So you got negative 6.5 times, whoops, what was it again? 2 and negative 5. 2 and then times negative 5. Now, remember the commutative property of multiplication. Whoop, focus. Sorry. It's not focusing for me. Autofocus. There we go. Okay. So the commutative property of multiplication says that it doesn't matter what order I go in, right? I can multiply I could say 2 times negative 6.5 times negative 5, right? Doesn't matter. I'm going to get the same answer. So if I multiply this across, I'm just going to go ahead and do this like this since I've changed them around. You don't have to. But, well, no. It's actually easier in my mind if I leave it this way and multiply these first. So I'm going to use the associative property and multiply those together first and then multiply it by this. Because what is 2 times negative 5? Negative 10. Thank you, Lucas. Negative 10. And now I've got negative 10 times negative 6.5. And every time you multiply a decimal by a 10, what happens? It's a nice, easy multiplication, right? Because we can say 10, 6.5. We just basically move this decimal over 1 because we're just making it 10 times bigger. But we have 2 negatives multiplied together too, and those 2 negatives come together to make a positive. So we get positive 65. Okay, see that? Abby's got a little friend there. Very cool. Dulcie, camera on, please. Thank you. All right, let's go to the next one. Next one is, word problem. But all we have to do in this one is find out where he made an error or if he made an error. So Jacob is showing us steps to solve the expression negative 27.8 divided by 1/7. In which step did Jacob make an error, or did he? I'll give you guys 30 seconds to take a look at that and see what you think. I need the Jeopardy theme song to play while you're thinking. Okay, Ramon. There we go. You guys hear the music? I see Patrick smiling. Do you hear Patrick?
Yeah.
Okay. All right. I'll pause there. That's about 30 seconds. Okay. So what do you guys think? Was there a mistake? Luke says yes.
Yes.
Who else said yes? Patrick? Patrick says yes. We got 2 yeses. Jessica, what do you think?
I don't know.
Not sure. Anyone else? Yes, Abby says. Okay, so far we're unanimous. Now, where is the error? Step 2, I think. Okay, so what is wrong with step 2? What do you think? What do you think he did wrong there? He multiplied after you already divided. Ah, okay. Any other thoughts? Jessica, you're in the not sure category, right? Or did you see something now? You see something? What do you think? Mm-hmm. Ah, so that's a good point. So Jessica said if you did step 1 and then you did step 2, you'd end up with the same thing. Because really, you know, dividing by 1/7 and then multiplying by 7 is kind of like opposite actions, right? All right. The only thing, though, and that's a really good observation there, Jessica. The only thing with this, though, is that after step 1, he didn't really change anything. He doesn't have a new answer, right? All he did is he changed this operation. He didn't do negative 27 divided by 1/7 and then write an answer and then multiply by 7. It's still negative 27.8, right? So what he did is he did the right step for dividing fractions. So when you're dividing fractions, I'll do this on paper so you guys can see this. When you're dividing fractions like this, you basically do what? You change it, don't you? Instead of dividing by 1/7, you could say it's multiplying by the, what's that fancy word? When you flip a fraction? Reciprocal. So we know that.
Precipitation?
Precipitation? Oh, it's a good science word. That means rain. That's what's going on right now outside. But no, let's say if you have a fraction like 3/4, right? The reciprocal of that is 4/3. That's just flipping it. So we say if you're dividing by a fraction, okay? Dividing by the fraction, and it's kind of the same thing as multiplying by its reciprocal, which is 7/1. Right? If I flip 1/7, I get 7/1. But 7/1 is just 7, right? So going back to, going back to Jacob, he did that. He just flipped it. And multiplied it by 7. And when you multiply by 7, you do get negative 194.6. So there is no error on this one. Looks like there is, but there's not. So that's the thing to take away from this. Write that in your notes, is that when you're dividing by a fraction, it's the same thing as multiplying by its reciprocal, by the fraction's flipped version. So let's say, just another example. Let's say I was dividing, let's just say I was dividing, I don't know, 3 divided by 1/4, okay? And let's think about this. 1/4, how many times could I get 1/4 into 3? The way I think about it is, I think, how many can I get into 1, right? So 1/4 can go into 1. Riley, you can't hear? Check your volume, because I think I'm not muted right now. No, I'm not muted right now. So just check your volume on your computer there. So if I've got 1/4, I can get 1/4.
I can hear you.
Good, thank you. I can get 4 1/4 into 1, right? And I think of it this way. How many quarters are in a dollar? A quarter is 1/4 of a dollar. If you got 4 quarters, you have a buck, right? So 1/4 times 4 equals 1. Another 1/4 times 4 equals 1. And one other 1/4 times 4 equals 1. You can't see my writing there. So that's 3, right? So I multiplied 1/4 4 times, 3 different times. So I did basically, well, 12. Well, anyway, so I can get 4 here, 8 here, and 12. So I've gotten 12/4 into my 3, if that makes sense. So if we do this fraction, like multiplication, what would we say? If 3 divided by 1/4 would be the same thing as 3 times what? Think of our reciprocal again. Four. Someone said 4. Riley the Great said 4. Yes, Abby said 4. Thank you. Good. And 3 times 4 is 12. There you go. That's another way to think of it. But just remember, divide by a fraction means multiplying by its reciprocal. All right, moving on. Diana made a recipe that yields 6.5 cups. Now that word yields is kind of weird, but all that means is it makes 6.5 cups. That's what you get out of it. So her recipe makes 6.5 cups. If each serving is 1/4 of a cup, we're going to write an expression that will help Diana determine the number of servings her recipe will yield. So we're basically just, whenever we have a word problem like this, it's always good to go, what do you know, what do you need to know? And what are you trying to figure out? Okay, Abby. So we know our recipe makes 6.5 cups, right? And we know each serving is 1/4 cup. We can put that in the things that we know. And we're trying to figure out how many servings, how many 1/4 cups can we get out of that 6.5 cups recipe. So what kind of crazy math could we do here to figure that out? I'll let you guys think about that for a second. And then I think we'll take a break pretty soon here. Oh. There you go. Yes.
I feel like we have to multiply the 6 and 1/2 times 2, so you can get 12 and 1/4, and then it's easier for you to find the answer.
Okay. So Jessica's suggestion is if you take the 6.5 and multiply that by 2, you'll get, what do you get? 12 and 1/4. Okay. And okay, so what would that tell? What does that tell you then? What does that 12 and 1/4 represent? The cups? Okay. All right. Any other thoughts? And Abby's back. Question, you should see it on your screen right now. So Diana made a recipe that's 6.5 cups. It makes 6.5 cups. Each serving is 1/4 cup. And we're going to try to write an expression that will help Diana figure out how many servings she can get out of a recipe. So Patrick, what did you think about this one? Any ideas?
Not really too much. You lost me after like the 35th word.
The 35th word?
I'm pretty sure, yeah.
Okay, well, with these word problems, the thing is to pick them apart, right? To pick them apart. So here's how I kind of go. Oh, Abby says 6.5 times 1/4. Okay, that's a good idea. All right, let's see. So I think I need a new color for this one. I need something yummy. Let's do orange. I don't know why orange is yummy, but it is. Okay, hopefully you guys can see this. So we know that the total recipe, right? Total recipe is 6 and 1/2 cups, right? And we know that each serving is 1/4 cup, right? So here's how I think about this. Let's say we have a pizza, right? And each serving of pizza is 1/8 of the pizza. Here's another example. I'll draw this over here. So our pizza, and each serving of the pizza is 1/8. We've just done that, okay? So there's like one serving right there. So how many people could that pizza serve? 7? Well, after you take that one out, yes, because there's only 7 left. But if you have the whole pizza, it could serve 8, right? So each slice is 1/8, and one pizza is 8 servings. I just took that one pizza, and basically, if you divide that by the number of servings you have, it tells you how many people you can feed. So 1 divided by 1/8, right? So we divided it by the serving, didn't we? So 1 divided by 1/8 would equal 8, because it's the same thing as 1 times 8. If I do my division there, right? If I do that little flip. And Lily is back. All right, so let's go back to our original question now. Our total recipe makes this. This is our serving size. So we want to know how many of these can we get out of that. Now what do you guys think? Someone said take the servings and multiply it by, I'm sorry, the total recipe and multiply it by the number of servings? Or what do you think may be a better idea there? Well, again, with our pizza, we divided, didn't we? We divided that pizza up among 8 people, 8 servings, right? We divided that. We said one serving is 1/8, so we divided that by 1/8, and we got 8 people we can feed. So we're going to do the same thing here. Anytime I want to find out how much of something can I get out of something else, I want to divide. I want to divide because I'm basically splitting that thing up into other smaller pieces. I'm splitting this 6.5 cups into these small 1/4 cup increments or bits, I guess. So I'm just going to say our equation would be our number of servings would equal the total divided by the size of the servings. What do you guys think about that? Well, let's see if it makes sense. Because if each serving is a 1/4 cup, we can get 4 1/4 cups into 1 cup, right? So we're at least going to have, we've got 6.5. So we're at least going to have, 4 times 6, which would be 24, plus another half, whatever that is. So we're going to have to have at least 24. So if we do this right and say 6.5 times 4, basically, right? Because that's I'm flipping my fraction. I'm doing the right step there, changing division into multiplication, flipping the fraction. But now I've got this mixed number here, which is never good. So I'm going to switch this to a compound or a improper fraction. I just like multiplying that way. So to change this to an improper fraction, what do I need to do? An improper fraction, again, is just, it's got a bigger number on top than the bottom because it's not really a fraction since it's more than 1 then. That's why we call it an improper fraction. But how do I change that to an improper fraction? Patrick, you're having a good time over there.
You multiply 2 times 6 plus 1.
Yes, thank you. Notice that Patrick's got this big smile on his face. He's really enjoying math, I guess. I don't know.
I love math. It's one of my favorite subjects.
Cool. All right. So I don't know if you guys can see this, but you work in a circle. You go 2 times 6 plus 1. So the denominator times the whole number plus the numerator. That's basically how we do it. So 2 times 6 is 12, plus 1 is 13. We have 13 halves times 4. Okay? Now, multiplying fractions by a whole number. Again, I'm just going to run through this so we can take a break. I'm just going to change this back to a fraction because remember when we multiply fractions, we multiply the numerators and then we multiply the denominators, right? And if there's no denominator, if it's a whole number, it's got the denominator of 1 automatically. So 13 times 4 is a big number, 52. Divided by 2 times 1 is 2. What's 52 divided by 2? And thank you, Ramon. 26. Good job. So we can get 26 servings. And that seems right? That's what I said. If we've got these quarter cups, we know we can get four servings out of 1 cup. And we've got at least 6 cups. So that'll be at least 24 servings plus a little more. That looks like 24 plus a little more. So we're good. Okay. All right, let's take a quick break. It's 10 o'clock right now. Let's be back at 10 after. And I have a few more questions to run through. You guys can turn your cameras off, mute, whatever. Take 10 and be back right at 10 till so we can get rolling. And I will mute myself too. If I can find where my mute button is. I don't know why that happens. There it is. It's there. Okay. That's the next question if we want to get a head start. Oh, and while we're on break, sorry, I should have said, take a look back at your social studies module 1 so you can answer those 3 questions for Ms. Powell when she gets back at 10:30.
You can't even see most insane. Hey dude, you know the farm you dug? I got a school bus minute. Yeah, we got ourselves a Marlin. I need you to push it out. I have nothing big enough to pull this thing out. Okay, so my man Dan is coming with these that's a reflection of donkey walking across the hill. I wonder if when I like ramp the GPR and the lights are still on. Why are the lights still working? These are big stuff. I bet you can literally grab it. Oh, I don't know what's on. I can just pull it off. Oh my God. Oh no. I'm close. Wipers are on. Look at the wipers. Pull that guy around. Oh, you shouldn't even get to the track again. Why is the power still on? I mean, I don't think it is off. Little trick.
Is this a break? I'm gonna go get some food.
Okay, everybody. It is 10:10. Let's get rolling. I want to try to finish up in about 15 minutes so I can talk real briefly about the science lab that was on the assignment list for yesterday for Science 7. So let's get rolling here. I'm going to kind of move through these a little bit more quickly. So make sure you're writing down the questions and how I'm solving them so you have them in your notes. All right, I'm gonna switch. I'm feeling green now. All right, so this question that's up on the board there, convert 3/8 to a decimal. Just real quick, what is it that we have to do to convert a fraction to a decimal? Luke already got it. Divide them. Perfect. So anytime you have a fraction, right, you're just going to divide it. So you're going to take your 3/8, and I don't know if you guys noticed this, but a fraction is a sneaky division problem. 3/8 is basically saying 3 divided by 8. Didn't know that? Now you do. So 3/8 is the same thing as 8 into 3. And if you do it with long division, I can't get 8 into 3, so I got to add a decimal up above and down below here. So I have now 30. I can get 8 into 30 at least 3 times. That's 24. I've got 6 left. 8 can't go into 6, so I'm going to add another 0 here and here. 8 can go into 60 7 times, which is 56. I got 4 left. I should put my minuses here so you can follow that. And 8 can't go into 4, so I'm going to add a 0, and 8 can go into 40 and even 5 times. So there's your answer, 0.375, as Luke said. Thank you, Luke. Good job. All right, focus. There we go. Oh, so I'm having a hard time focusing today. Okay, next. I thought I had a little light on there too, but I guess not. The steps to convert 23/4 to a decimal are shown below. So he just did exactly kind of what I just did, but with a different fraction. So where is the error in this one? And I'll give you a hint. There definitely is an error this time. So this time there's definitely an error. So he's done something wrong here. What do you guys think? You can walk through the steps.
4 times 7.
Sorry, 4 times 7?
Yeah.
Oops. So what step? I don't see where he did 4 times 7. So step 1, let's go through these together. Step 1, he got 20 here. And he figured out, okay, well, 4 can go into 23 at least 5 times. And 5 times 4 is 20. He subtracted that out. He got 3. So far, so good, right?
Yeah.
All right. Step 2, he added a 0, which you should do because he can't get 4 into 3. So he's got to add that 0 so he has more to work with there and can continue on. 4 does go into 30 7 times. But 7 times 4 is?
It's 28, and it's wrong.
28. So he made a mathematical error right there. He made what we call in sports a rookie mistake. So remember your times tables. All right, so step 2, that he made the mistake. All right, moving on. Tucker earned $12.50 walking dogs on Saturday. On Sunday, he spent $6.95 when he purchased a movie ticket. This must have back in the good old days. Movies are a lot more expensive now. He needed to borrow money from a friend to complete his purchase of a snack. Okay. So basically, after he spent his money at the movies, he didn't have enough to buy a snack. So his snack cost more than what he had. And we want to know, how much money did did Tucker pay for his snack if he owes his friend $5? So this is a little tricky. And Luke, is this your answer for this one? 575? Oh, okay. Oh, you got that was the last one we were doing. Thank you. Yeah, I should have solved what the actual answer was, but I didn't. We were just wondering where his mistake was, but thank you. All right, let's walk through this one. Here's kind of what I do with a question like this. So again, taking what do you know, what do you need to know, and what are you trying to find out, right? So we know, we know that I'm going to make a T-chart here. I'm going to make a plus and a minus, and you'll see why in a second. So we know that there was some money going in and out here, right? So Tucker earned some money, he spent some money, he borrowed money from a friend, so he got more money, and he spent some money on a snack. So I look at it this way. I saw, well, he started with $12.95. That's on the plus side. This is kind of an accounting thing, I guess. And he spent $6.95 on the movie. So I'm gonna put $6.95 over here. I'm not putting a negative because this is just implied that this is all stuff he's lost, money he's lost. He also bought a snack. So he spent money on a snack, but we don't know what that is. So I'm just gonna write snack there. And we know that he owes his friend $5, right? So that implies that his friend gave him $5, right? So I'm going to put that in the plus side because he got an extra $5 there. Now, we know that all this stuff has to even out in the end, right? After he pays back his friend, he's not going to have any money left, and his friend will have the money he got borrowed back, so everyone will be happy. So his total earnings here, if I add these two numbers up, I get, oh, hold on a second. I wrote something down wrong. I did this before when I did this last night. It's $12.50. Thank you. $12.50. So that is 55. 12 plus 5 is 17. So he had $17.55 and he spent all of that. So he spent $6.95 plus this snack, right? Snack with a C. So we know.
Isn't it
that,
$12.50?
What's that?
Isn't it $12.50 and not $12.55?
You're probably right. You're absolutely right. Thank you. Absolutely right. I knew I did something wrong there. There, $17.50. So $17.50, the total he had in his pocket after he borrowed his money, should equal what he spent on the movie plus his snack, right? So how could we figure out from that what the snack is? Patrick, are you smiling because you know the answer and you just don't want to share?
No, he's not smiling.
No, he's not smiling. So Patrick, now's not the time to be watching YouTube. So, subtract. There you go. So if I subtract what? $6.95 from what? Yes, from $17.50. So if this plus this equals this, then this minus this would equal the snack. Let me just rearrange it. I think you learned about fact families back in 6th grade. So that's kind of going back to fact families. So if you subtract that out, I've already got the answer. I'm just going to write it here. You get 1055 if you write down what he actually started with correctly, which I didn't do. So 1055 is the correct answer there. That equals the snack. That's an expensive snack. I'm thinking snack like a Snickers bar, like, you know, $1. Anyway.
Not as movies.
Yeah, not at the movies. That's true. Red vines are probably that, that much there. All right, let's get a couple more here. Matt is making cookies, and I want some. He adds 3/4 of a cup of sugar to a bowl. 3/4 of a cup. He then removes 2 1/8 cups of sugar. So he's taking some out again. How much sugar does he have left in the bowl? Okay, so again, he adds 3 cups of sugar to a bowl, 3/4 cups of sugar to a bowl. He removes 2 1/8 cups of sugar. How much does he have left? And Luke, 0.625. Okay, so you did it in decimal form. Not quite right, though. That's how you do everything. Well, that's good. I mean, you could do it that way, for sure. You could definitely do it that way. I'm going to do it with fractions, though. I'm going to do it with fractions. So, oops. Let's say, scooch over to this side now. He starts with 3/4 of a cup, and it said that he took out 2/8 of a cup, right? So just make sure I write this down right. 2 1/8 cups. We could agree that that would be 2/8, right? You probably just took out 1/8, didn't you? So 2 1/8 cups. So 2 1/8 cups would be, you took out 1/8 and then you took out another eighth, right? Like that. But I'm just going to say it would be 3/4 minus, I'm not equals, minus 2/8, right? Because if you take out 2 1/8 cups, that's basically 2/8. Now, I can't do this subtraction. And yes, Luke, you got it. I can't do this subtraction as it is. I've got to convert some of these things to, so I have the same denominators. So I have the least common denominator. Multiply by 2. Absolutely. I'm going to multiply this side by 2. 2 on the top, 2 on the bottom. And I get 6/8 minus 2/8. Now I can do the math, right? And again, just pointing out, if I multiply this right here by 2/2, what's 2/2? 1, right? It's just 1. So I haven't changed it, right? If I multiply something by 1, I haven't changed it. But when I multiply it in a fraction like this, I can change the way my fraction looks, but it still has the same value. 6/8 is the same thing as 3/4. Okay? So 6 minus 2 is 4/8. And 4/8, I can simplify that, right? To be 1/2. If you guys can't see that, I will show you. If I divide both the top and the bottom by 4, again, I'm changing it by just a value of 1. 4/4 is 1. That would equal 4 divided by 4 is 1. 8 divided by 4 is 2. Got it? I know I'm going through this a little fast, but again, being recorded, so if you need to go back and review the video, you can. Oops. All right, last one real quick.
My computer died, I'm
let's
sorry.
see. What's that?
My computer died.
Oh, that's okay.
Well,
Last
like
question real quick. All right. A dolphin dove 31 meters below the surface of the water to reach a fish.
That's far.
That's far. Pretty deep. Dolphins can dive pretty far, though.
31 meters is like
16% of
12
the
miles.
total distance. So 16% of that 31 meters every second. So this one's a little tricky. What are some things that we could do to figure out how, or the total distance that the dolphin swam in 3 seconds? That's what we're trying to figure out here. So a dolphin drove 31 meters to get to a fish. It traveled 16% of that 31 meters every second. And we want to know after 3 seconds, how deep was the dolphin? Any ideas, real quick? I need a new sheet of paper for this one.
Maybe 3 times 16.
3 times 16. Ooh, I like it. Because if he did 16% in 1 second, then after 3 seconds, it would be 3 times that 16%, right? So let's see if that works. So 31 meters total. 16% in 1 second. So that means in 3 seconds, that would be 48. And I'm dealing with percents there. So 48%. There's 2 ways you can do this. That is one way. So now we need to figure out, well, okay, he's made 48% of the distance.
1.44.
What is it?
1.44.
1.44.
Yep.
What is that? 48% of 31?
No. So times 3 times times 3 by 48%.
Okay, well, so I hear what you're saying there, but what we're doing here is actually we're keeping this in percent. We just want to find out what percentage of that distance he went in 3 seconds, and he went 48% of this 31 meters.
Oh.
Does that make sense? So now we have to figure out what's 48% of 31? How do we do that mathematically without a calculator? .88.
So you times
14.88.
48% times 31 meter.
Right.
And then whatever the answer that is, you add a decimal point.
Okay, well, 48%, how do I convert that to a decimal? Wouldn't I want to convert that to a decimal first and then multiply?
4.8.
Almost. One more over.
48.
0.48.
Oh.
0.48 times
Yeah.
31, and that does equal, as Lilia said, 14.88.
I said that. I'm not Lilia. That's
Oh, no,
Patrick.
Lilia typed it. You don't see that. She typed it to me privately, but she said
Oh.
it's 14.88.
Darn it, Lilia.
You both got it. You both got it. Yeah, I rounded. You're right, Luke. It is a not a perfect fraction there. All right, that's one way you can do it. The other way you could do it is figure out what is 16% of 31 meters, and then multiply that by 3.
Yeah.
So you can do it 2 different ways. All right, I'm going to let Ms. Powell take over, but real quick, I wanted to talk to you about science just really, really briefly. See here. It is assignment 2.03 here.
For today?
Well, it was actually due yesterday, but there were some questions on this as far as what to do. So
Oh, I got it right, didn't I? Email FaceTime you.
About this assignment?
Yeah, yesterday. It was the
Yeah, I think we went over this. I don't remember. But it's this light lab here. So this light lab is, first of all, it's nothing that you come to campus for. It's just you do this at home on your computer. But it's a little confusing as far as where to go. So once you open up this lesson here, it talks you through some things about light, about refraction, reflection, and
mostly
go through
refraction.
a couple of these little bits of information here. But the main lab is all the way down at the bottom. So the questions that you're answering have to do with this down here. This is kind of small on my screen here, but it's this right down here. Oh, wait. Is that it? Yeah, that's it. It's this at the very bottom where you see the sun and refraction. And the questions are basically what you think is going to happen with these 3 different mediums. So the sun's going to go through water, through a window, and through a
diamond.
Yep. All right. And that's all it is. That's all it is. So there was some there. If you have a chance, do this at home. because this is kind of cool to see. If you have a cup that's not clear, drop a coin in it and then fill it with water and look at it from an angle like this and see if you can make the coin disappear when the water is not in there. It's kind of cool. That's
Definitely.
refraction. Yes.
And for question 2 or 3, I think it was for this.
Uh-huh.
Was it like after it goes through the water, does it go through the window from the water, or does it just go? It's a second
No, it
medium.
talks about 2 mediums. It's like from the air to the water, or from the air to the diamond, or from the air to the window.
Okay, my dad was trying to get me to do from the water to the window, and I got confused, but I did my answer, and I think I got it correct.
Okay, good. All right, well, I'm going to hand this over to Ms. Powell so she can finish hers. And
Have they taken a break out?
yeah, they took a break.
They did.
Yeah. Are you ready?
Uh-huh.
Okay.
Yeah. I just wanted to actually give them
Nah, I gave them a break. Let their fried math brains rest a little bit. Oh, let's see. I got to stop sharing.
All right.
There we go.
Okay, so hopefully over break time, I know it's not much of a break when you're kind of studying through things, but hopefully everybody took a little moment during break time to go back over their module 1 for social studies.
I reminded.
Okay, because then we can finish this up. We have just a little less than half an hour to do so. So just a quick reminder before I put you back into your breakout rooms. You want to think about just basically when I have you think of 3 things from the module, it's just to try to get your brain back into that space to remember what the module is about. Because then once you've generated an idea of like, oh yeah, that's right, we did this and we did this, we did this, then it's easier to answer the last 2 questions. So that first question is really about just getting you back into that space. So I'm going to put you back into breakout rooms. I don't know that it'll put you into the exact same ones, but we can play with that a little bit here. Where did my breakout rooms go? Oh, there we go. Okay. So, oh, and we have a couple new people here too.
Yes.
Okay, so again, as a reminder for me, Lilia and Logan, the 2 of you have completed this, correct? Is that right?
Yeah.
Okay.
Yes. Is it social studies DBA or language arts DBA?
Social studies.
Then I did this because I called you.
Patrick. Yes.
Yes.
You know, the other